Let me discuss about the mass transfer operations. What is mass? Mass is refers to the quantity of matter in an object. The mass is a fundamental property of object, a numerical measure of its inertia and fundamental measures of the amount of matter in the object. Weight. Weight is the gravitational force acting on a body of mass. W is equal to m into g, where m is a mass, W is a weight. So g is acceleration of gravity. So definition of mass. Mass transfer is the net movement of mass from one phase to another phase due to stream or phase or fraction or component to another. Mass transfer occurs in many processes such as absorption, evaporation, adsorption, drying, precipitation, membrane filtration, and distillation process. So next, introduction of mass transfer operations. For example, when a system contains two or more components whose concentrations vary from point to point, there is a natural tendency for mass transfer to be transferred, minimizing the concentration difference within a system. The transfer of one component from a region of higher concentration to the top lower concentration is called mass transfer operation. In general, the mass transfer is defined as transfer of mass from one phase to another phase due to concentration gradient or temperature gradient or pressure gradient. The transfer of mass with a fluid mixture or across a phase boundary is a process that plays a major role in many industrial processes. For example of such process are dispersion of gas from stacks, removal of pollutant from plant, discharging streams by absorption, stripping of gases from wastewater, and neutron diffusion within nuclear reactors and air conditioning. In real in real examples, many of our many of our day by day experience also involve mass transfer. For example, a lump of sugar added to a cup of coffee eventually dissolves and then eventually diffuses to make the concentration uniform. And also water evaporates from pond to increase the humidity of passing as steam. Perfumes present a pleasant fragrance which is imported throughout the surrounding atmosphere. The mechanism of mass transfer involves both molecular diffusion and convection. The common examples of mass transfer operations. The sum of the common examples for a mass transfer process are the evaporation of water from a pond to the atmosphere, and the purification of blood in kidneys and liver, and also the distillation of alcohol process. In industrial process or mass transfer operation includes separation of chemical components in distillation columns, absorber such as scrubber, adsorber such as activated as a carbon beds, and liquid extractions. A number of unit operations are carried out in chemical engineering applications which do not involve chemical reactions. These operations are carried out for the separating either component by mechanical means like screening, filtration and salting, or increasing its concentration in a mixture. The general definition for mass transfer is transfer of mass from one phase to another phase is called mass transfer operation due to concentration gradient. These are the classification of mass transfers. There are three types. First one is liquid operation, gas liquid operation, fluid solid operations. The fluid solid also denoted as solid liquid or gas process. The gas liquid operations are absorption, desorption, humidification, dehumidification, distillation. These processes are called gas liquid operations. In these operations, there are two phases are involving. One is gas, another one is liquid process. In for absorption process, what will happen? The transfer of solute from a gas mixture to a solvent. For the example are the removal of ammonia gas from byproduct of coke ovens using water. Here, water is a solvent, ammonia gas is a solute, the desorption. This is the reverse process of absorption process. The example are the removal of ammonia from ammonia water solution using air, humidification, transfer of liquid to gas phase, transfer of liquid to gas phase, example contacting dry gas with pure liquid, dehumidification, transfer of a vapor component from a gas vapor mixture to a liquid phase by contacting them. This process is reverse process of dehumidification process, example transferring water from air water vapor mixture to liquid water. Distillation, this process is many chemical industry are using the distillation process. In this method of separating component in a liquid mixture by distribution of substance between a gas and liquid phase is known as distillation process. The method of separation depends on the relative volatility and cases where all components are present in both the phases. Example, separation of petroleum fractions by application of heat. So distillation majorly plays a vital role in alcohol industry and petroleum process industry. Then next we move on to liquid operation. Liquid operation contains extraction operation, only extraction operation. In this operation, the two phases are liquid. The separation of component that is solute from a liquid mixture using another insoluble or partially miscible solvent is known as extraction. The two phases are available. One is extracting phase, another one is raffinate phase. In extracting phase contains solvent rich phase extract and residual phase containing liquid phase raffinate. Example, separation of dioxin from water, dioxin solution using benzene as a solvent. Next, we move on to solid liquid or gas operation. In this operation involving three, both solid liquid or gas phase. The three phases are involving in this process. For example, the process are drying, adsorption, leaching, and crystallization process. Drying, the removal of moisture from a substance. Example, removal of water from a cloth, paper. Adsorption. Adsorption involves contact of solid with either a liquid or gas mixture in which a specific substance from the mixture concentrate on the solid surface. This process is adsorption process. Adsorption process mainly involves in wastewater chemical industries. Example, the majorly removal of color from solutions using activated carbon. Adsorption process, only surface phenomena involved. Leaching, separating a soluble solute from a liquid mixture by contacting it with a solvent is known as leaching. Example, separation of oil from oil seeds using hexane. Here, hexane is a solvent. Then crystallization, the process of forming solid particle within a homogeneous phase. Example, the formation of crystals of sugar from a concentrated sugar solution. Then next we move on to distillation process. This is the major process used in petroleum and alcohol industry. Distillation majorly separates based on the boiling point difference. So, what is distillation? It is a process in which liquid or vapor mixture of two or more substance is separated into its component fractions of desired purity by the application and removal of heat. This process is known as distillation process. Distillation process majorly separates based on the boiling point difference. So, introduction of distillation process. Distillation is a most common unit operation in chemical industry in which the components of liquid mixture, that is solution, are separated using thermal energy. The distillation columns are designed to achieve this separation efficiently. This technique it is possible to separate a liquid mixture into its components in almost pure forms. Distillation principles are the separation of component from liquid mixture via distillation depends on the difference in boiling points of the individual components. Based on the boiling points, the component were separated. Also, depend on the concentration of components present in liquid mixture will have different boiling point characteristics. Therefore, the distillation process depend on vapor pressure characteristics of liquid mixtures. What is vapor pressure and what is volatile? The vapor pressure or equilibrium vapor pressure is the pressure exerted by a vapor in thermodynamic equilibrium with its condensed phases, that is, maybe a solid or liquid, at a given temperature in closed system. The equilibrium vapor pressure is an indication of liquid's evaporation rate. So the vapor pressure is a major role in liquid evaporation rate. That is the indication of the evaporation rate. It relates to the tendency of particles to escape from the liquid or solid. Majorly, volatile means the tendency of particle to escape from liquid or solid. A substance with a high vapor pressure, what will happen at normal temperature is often referred as a volatile. So, its general definition of volatile is tendency of particle to escape from liquid or solid phase. This called volatile process. And what is more volatile component and less volatile component in a binary mixture? The component with lower boiling point or with higher vapor pressure at a given temperature termed as the more volatile component. In binary mixture, the component having lower boiling point with higher vapor pressure means that is called as more volatile component. In one component having higher boiling point or lower vapor pressure at a given temperature is termed as less volatile component. The volatile majorly depend upon the component with have higher boiling point or with lower pressure means that is a less volatile component. In that same component having lower boiling point or with higher vapor pressure at a given temperature means that termed as more volatile component. This is the difference for more volatile component and less volatile component. And what is boiling point? This is a major role in distillation column. For any given pressure, a pure liquid when heated will boil or vaporize at a certain temperature is known as boiling point of the liquid. So, boiling point means what? At a given pressure, the pure liquid heated will boil or vaporize at a certain temperature. When will boil or vaporize at the temperature is known as boiling point of the liquid. For example, boiling point of the water is 100 degrees Celsius. Once the water reaches 100 degrees Celsius, automatically the vapor will release. And toluene having 110 degrees Celsius. Methanol 64.7 degrees Celsius at 1 atmospheric pressure, that is 101.325 kilopascal. For a binary mixture of methanol and water, methanol is more volatile and water is less volatile. Based on the definition of what is more volatile means less boiling point and more vapor pressure. And less volatile component means more boiling point, less vapor pressure. And then we next move on to what is partial pressure. The partial pressure of component of which is present in the mixture of gases is the pressure exerted by component if it were alone taken into container having the same volume at the temperature as the gaseous mixture. And next move on to what is equilibrium and what is the driving force. In distillation column, these two are very important parameter. Equilibrium, it is the condition at which transfer of material ceases, that is stop, for a given set of operating conditions that exist for all combination of the phases. So equilibrium means once the process at attain equilibrium, after that there is no change in that process, that is called equilibrium process. What is driving force? When two phases are brought into intimate contact, the phases will tend to approach equilibrium. Once the phases are contact with each other, automatically the phase will tend to or move to equilibrium process. Due to tendency for change to take place. The difference between the existing condition is called driving force of mass transfer. The difference between exist condition is called driving force of mass transfer. And next we want to volatility. Chemistry and physics, volatility is the tendency of substance to vaporize. In generally, the volatility means tendency of substance to vaporize. The volatility is directly related to a substance vapor pressure. So volatility is directly related to a substance vapor pressure. At a given temperature, a substance with higher vapor pressure vaporizes more readily than substance with lower vapor pressure. These are the nomenclatures of phase transitions. What is vaporization and what is evaporation and what is boiling and what is sublimation. So first we know that what is vaporization. The vaporization of element or component is phase transition from liquid phase to gas phase. So in this process, vaporization process, the transfer of phase transition between liquid phase to gas phase. This is called vaporization process. There are two types of vaporization. So that is evaporation and boiling. Evaporation. What is evaporation? Evaporation is a transition from liquid phase to gas phase that occurs at temperatures below the boiling point. So the transition occur liquid phase to gas phase occurs temperature. What is temperature means the below the boiling point temperature at a given pressure. This process is known as evaporation process. The evaporation usually occurs on the surface. So evaporation majorly where will happen means it is occur on the surface. And boiling, next we on to boiling point, is a phase transition from liquid phase to gas phase that occurs above the boiling temperature. Boiling as opposed to evaporation occurs below the surface. So the evaporation means evaporation when will occur below the boiling point temperature at the given pressure. In boiling means above the boiling temperature. Sublimation is a direct phase transition from solid phase to gas phase. There is no intermediate change. It's skipping the intermediate liquid phase. These are the common nomenclature for different phase transition, that is vaporization. These are the different process of nomenclature that are vaporization. Vaporization again separated into two types, that is evaporation, boiling. Vaporization, boiling and sublimation. What is dew point and bubble point? In distillation process, in these 2 points are very important, dew point and bubble point. Already, Already we know dew point is a temperature at which the saturated vapor starts to condense. When the saturated vapor start to condense gas to liquid means that point is known as dew point. The bubble point is a temperature at which the liquid starts to boil. When the liquid starts to boil at the particular temperature is known as bubble point temperature. These are the two dew point and bubble point process. And next we move on to relative volatility. Relative volatility is the ratio of volatile of A, more volatile component. A means the more volatile, we are taking as more volatile component, to the top B. B means less volatile component. The notation is alpha AB. For an ideal system, the volatility is equal to the vapor pressure of pure component. For an ideal system means the volatility is equal to the vapor pressure of pure component. Alpha is equal to 1 means it is separation of distillation is not possible. So the relative volatility is equal to 1 means the separation by distillation is not at all possible in this process. The separation by distillation is not possible. The relative volatility is greater than 1. The larger value of relative volatility is here the separation by distillation. The range is 2 to 4. So the alpha, that is relative volatility, plays a vital role for separation process in distillation operation. It means alpha is equal to 1 means the separation of distillation is not possible, and also even relativity greater than 1 means it is also not possible, but it is above the larger means a larger value means 2 to 4. The range of relativity maximum separation is possible 2 to 4, the range of relativity. At that range the easier separation by the distillation process. The methods of distillation. The methods of distillation refers two methods. One is with reflex, another one is without reflex. With reflex, major of the chemical industries is using for this process. What is with reflex? The liquid mixture is heated to create a vapor. All the vapors formed are condensed at a condenser and withdrawn as a product. As there is no reflex, products of relatively low purities are obtained. This is the with reflex. With reflex means one part of the distillate again sent back to the distillation column. In what will happen? Again, more contact of gas and liquid phases, the mass transfer rate is high. At that time the separation efficiency also increased, the product purity may be increased. Without reflex maximum using for only laboratory purpose. The liquid mixture is heated to create a vapor. All the vapors formed are condensed in a condenser. A part of the condensed liquid is returned to the distillation system as a reflex and remaining part withdrawn as a product. This method and vapor are brought into intimate contact number of times and almost pure product can be achieved. The difference between laboratory scale distillation and industrial distillation. The main difference between laboratory scale distillation and industrial distillation is that laboratory scale distillation is often performed batch wise, whereas industrial distillation often occurs continuously. So, in for laboratory, there is a batch process. In industry, it is a continuous process. This is the major difference for laboratory scale distillation and industrial distillation. In what will happen in batch distillation, the composition of the source material, the vapors of the distilling compounds and the distillate change during the distillation process. In batch distillation, a still is charged or supplied with a batch of feed mixture, which is then separated into its component fraction, which are collected sequentially from most of volatile to less volatile with the bottoms, remaining at least or non-volatile fractions removed at the end. The still that can be recharged and processed repeatedly. The feed will be recharged, the process will be stopped, and the feed will be again uh, recharged, then the process will start. But it is continuous process. The feed will fed continuously to the process and product with donors continuously. In this process, that means the laboratory process, once the feed is fed, egg and product is collected, after that again recharged to the feed to the distillation column. In continuous distillation, the source materials or vapors and distillate are kept at constant composition by carefully replenishing the source material and removing fractions from both vapor and liquid in the system. This result in a better control of the separation process. The continuous, that is laboratory, compared to laboratory distillation, the industrial distillation is very effective and more purity of the product is collected and efficiency will be increased. The time also, the time consuming is less. Next, we want to laboratory scale distillation. The laboratory scale distillation almost exclusively run as a batch distillation. I already told that there is a batch distillation process. The device used in distillation, sometimes referred to as still, consists at a minimum of reboiler or pot in which the source material is heated, a condenser in which the heated vapor is cooled back to the liquid state, and a receiver in which the concentrated or purified liquid is called the distillate is collected. And this is the application of distillation process. The application of distillation can be roughly divided into four groups. One is laboratory scale distillation, industrial distillation, distillation of herbs for perfumery and medicinal, that is herbal distillate, and food processing. The latter, they are two distinct from former two in that the distillation is not used as a true purification method, but more to transfer all volatiles from the source material to the distillate. This is the setup for simple distillation. Simple distillation contains heat source and one round bottom flask. In round bottom flask, we kept feed mixture. In that feed mixture having more volatile component and less volatile component. In more volatile component, the example of ethanol and water, in which the ethanol is the more volatile component. The more volatile component is less boiling point, high vapor pressure, and another one is a b, that is in this process we are using water and ethanol. The ethanol is more volatile component and water is less volatile component. Less volatile component means high boil compared to ethanol, the water is high temperature and the vapor pressure is high vapor pressure, less vapor pressure. This is the less volatile component. And in round bottom flask, the thermometer is insisting. After that, it moved to the, we are heating the bottom of the round bottom flask. The heated. Once the temperature is reached, the vapors are moved to the condenser. In that condenser, the outer jacket, hold water is flowing. In this process, the gas is converted to liquid. and in bottom of the condenser were collected as a product as distillate in and remaining process kept in bottom round bottom flask, that named is residue contains more volatile component, sorry, less volatile component. In the distillate contains more volatile component. This is the simple distillation process. It is majorly used for laboratory purpose. It is a batch operation process. So, what is simple distillation? It is to verify the Rayleigh's equation for simple distillation. This is the very important equation to find out the number of stages, or what is the bottom product and top product of the distillation process. Simple distillation is the process consisting of infinite number of successive steps for flash vaporization, where in which each step in infinite small portion of liquid is vaporized and the resulting vapor that is in equilibrium with the liquid is removed. Simple distillation is a batch process. It is majorly used for laboratory purpose. It is the simple distillation commonly used in laboratory, not in the industrial purpose. This operation is used to separate liquid whose components having fairly large difference in their boiling points. We are taking the two components, that is one is more volatile component, another one is less volatile component. In that component having the boiling point difference is very high, at the time only the simple distillation is employed. This type of distillation is frequently employed in laboratory and pilot plants to concentrate one component in the distillate or residue. So, distillate having more volatile component, it is a top product of the distillation column, and residue having bottom product, it is having less volatile component. It is also used for analytical evaluation of boiling range of mixers. So, and we already told that the Rayleigh's equation is very important for calculating the simple distillation process. That is, ln of F by W is equal to integral of xw to xf dx by y star minus x. In this process, where F means kg of mole we feed. Feed contains A and B. A is more volatile component and B is less volatile component. W means kg of moles of residue. In residue is collected bottom of the round bottom flask. And XF means mole fraction of more volatile component in feed. In that feed containing more volatile component and less volatile component. We are taking only for more volatile component fractions, mole fractions. We didn't take the less volatile component for the calculation. And XW, this also taking more volatile component mole fraction. So mole fraction of more volatile component kept in round bottom flask, it is collected as a residue. In that process the residue contains more volatile component, that means the XW, that is mole fraction of more volatile component in residue phase. Y star, equilibrium mole fraction of more volatile component in vapor. And X means equilibrium mole fraction of more volatile component in liquid. The Rayleigh's equation holds well under the following assumptions. The assumptions are: the composition of liquid is uniform, the process is carried out slowly so that vapors leaving the still are in equilibrium with liquid in the still. There is no entrainment of the liquid. There is no condensation of vapor before it reaches the condenser. For an ideal system, the relative volatility alpha is a constant. For ideal system means alpha is constant, and Rayleigh's equation gives the equation ln of F into XF divided by W into XW. So F means feed W means residue. XF means moles of mole fraction more volatile component present in feed. XW means mole fraction of more volatile component present in residue. It is equal to alpha AB, the relative volatility average, ln of F into 1 minus F XF divided by W into 1 minus XW, where alpha average is the relative volatility of the system between XF and XW. The alpha XW is equal to Y star minus divided by 1 minus Y star, the whole divided by x into 1 minus x at xw. Alpha x is equal to y star minus divided by 1 minus y star into x divided by 1 minus x at xf, and alpha average is equal to alpha xf into alpha xw power zero point 0.5. This is the procedure for simple distillation. In simple distillation, batch of liquid is charged to a kettle or ask fitted with some sort of heating device. In charge is boiled slowly and vapors are withdrawn as rapidly as they form in the condenser, where they are liquefied and the distillate collected in the receiver. The vapor leaving the flask at any time is in equilibrium with the liquid in which the flask, but since the vapor is richer in the more volatile component, the composition of liquid and vapor are not constant. This is the first portion of the distillate will be the richest in the more volatile component. And as a distillation proceeds, the vaporized product become leaner. That is more volatile component. It is called as distillate. The distillate can therefore be collected in several separate batches to give a series of distillation product of various purity. The next we move on to packed distillation process. In this process, the packing will be used in this process. The packed towers used for continuous contact of the liquid and gas in both countercurrent and co-current flow, or vertical columns which have been filled with packings for devices of larger surface area. The liquid distributed over and trickles down through the packed bed, exposing a large surface to contact the gas. Though in packed tower, the contact between gas and liquid will be more, so the mass transfer rate will be increased. The purity of the product may be increased compared to remaining distillation column. The packings are two types. One is random packing and another one is regular packing. So random packing means it is simply dumped into the tower during installation and allowed to fall at random. So random packing means the packing materials are simply dumped into the distillation column. There is no arrangement of the packings installation. After that, generally, the random packing offers large specific surface area for smaller size. You are using smaller size packing materials means it having larger surface area, but the cost less per unit volume in the larger sizes. Regular packing or greater variety. The regular packing offer the advantages of low pressure drop for the gas and greater possible fluid flow rates, usually at the expense of more costly installation rather than random packing. The regular packing offer the advantages of low pressure drop for the gases and greater possible fluid flow rates, usually at the expense of more costly installation rather than random packing. The packings are arranged properly. To find the packed distillation column for the equivalent to a theoretical plate, that is height equivalent to theoretical plate, in the packed distillation column we have to use to calculate the HETP. It means theoretical height of theoretical plate. A packed column of total reflux for a binary system of ethanol water by using Fensky equation and Mercaptile method. A packed tower can be used as a fractionating column for either continuous or batch. In packed column, The vapor liquid contact taking place in continuous bits for packing rather than individual plants. This is the packed distillation column. In that distillation column, we are packing materials filled with regular packing. In round bottom flask, the heating mandel is used. In round bottom flask having more volatile component as well as less volatile component. That is the binary mixture. It is heated. The vapors are moving to the packing section. After that, it moved to the condenser. In that condenser, the vapor phase converted into liquid phase. After that, we are collected as a uh, distillate in bottom product having residue. So in that process, we are comparing batch distillation or simple distillation. The purity and the separation efficiency will be high because the contact between gas and liquid is more due to packing material present in that distillation column. The contacting occurs in differential increments across the height of packing. The type of packing used is racing rings, Bursal paddles, ball rings, etc. The packing may be of two types. One is random, another one is regular. The pressure drop in theoretical plate is less than that for a sea or bubble cap tray, which an advantage. Then we will move on to simple distillation. Sorry, it's steam distillation. Steam distillation is a special type of distillation. Majority it is used for heat sensitive material, that is temperature sensitive material like natural aromatics components, etc. Many organic components tend to decompose at high sustained temperature. Separation by normal distillation would then not be an option, so water or steam is introduced into the distillation apparatus. By adding water or steam, the boiling point of component are dispersed, allowing them to evaporate at lower temperature, preferably below the temperature at which the deterioration of the material becomes appreciable. If the substance to be distilled are very sensitive to heat, steam distillation can also be combined with vacuum distillation. After distillation, the vapors are condensed as usual, usually yielding two-phase system of water and organic component, allowing for decantation. The principle of steam distillation is mixture of two partially miscible liquids are heated while being agitated to expose the surface of both liquids to the vapor phase. Each component independently exerts its own vapor pressure as a function of temperature, as if the other component were not present. Consequently, the vapors of the whole system increases. The boiling begins when sum of partial pressure of two immersible liquids just exceed the atmospheric pressure, approximately 101 kilopascal at sea level. In this way, many organic components insoluble in water can be purified at a temperature well below the point at which decomposition occurs. For example, the boiling point of bromobenzene is 156 degrees Celsius and the boiling point of water is 100 degrees Celsius, but a mixture of the two boils at 95 degrees Celsius. Thus, the bromobenzene can be easily distilled at a temperature 61 degrees Celsius below its normal boiling point. These are the application of distillation. Steam distillation is employed in the manufacture of essential oil for use in perfumes. In this method, the steam is passed through the plant material containing desired oils where it is commonly referred as steam stripping. Thank you.